Yes, last class
Yes.
what we did?
Yes.
State and prove perpendicular axis theorem. Next is state and prove parallel axis theorem. I am writing AXES plural of axis. State and prove parallel axis theorem. Statement. Perpendicular axis theorem was valid only for planar body, but parallel axis theorem is for any bodies. I means moment of inertia, O means any axis, IC is moment of inertia about IC is moment of inertia about center of mass, M is total mass, R is square of distance between two parallel axes. So this particular equation is actually parallel axis theorem. That means if this is rigid body rotating about any axis passing through O, then moment of inertia is about parallel axis passing through center of mass plus mass into square of distance between two parallel axes. That is called parallel axis theorem. So looking at this equation, I am framing my statement. Moment of inertia of a rigid body about any axis is equal to the sum of moment of inertia of rigid body about parallel axis passing through center of mass and product of mass and square of distance between two parallel axes is called as parallel axis theorem. That is IO equal to IC plus MR square. Just read and see whether you have followed or not. If not, then again I will explain. Understood the statement written?
Yes, sir. Follow.
Okay, please write this definition. Then we'll prove whether it is really IO equal to IC plus MR square. Completed writing?
Yes, sir.
Okay. Now we'll prove IO equal to IC plus MR square. Proof. This is rigid body rotating about an axis passing through O, parallel axis passing through center of mass. This is R. T is particle of mass Mi. Draw OP, draw PC, draw PD perpendicular to OC extended up to D. Please complete this much again. Rigid body rotating about O, parallel axis passing through C. P is a particle of mass Mi, join OP, join PC. Then PD is perpendicular to OC, extended up to D. Consider a rigid body of mass capital M rotating about an axis passing through O. Let a parallel axis passes through center of mass C. Let P be particle of mass Mi of rigid body. Draw OP, draw seg OP, comma seg PC. Also draw seg PD perpendicular OC extended up to D. Complete till this, then we'll see how to get IO equal to IC plus MR square. Let IO comma IC be moment of inertia about an axis passing through O and C respectively.
forgot about chasing this self.
Yes, done till this?
Yes, sir. Done.
Yeah, everybody is done. Can I clear this off?
Yes, sir.
Okay.
Now, all of you look in the diagram. Can you see right angle triangle? Larger right angle
Yes.
triangle. Name it.
POD.
Yes.
Beudi? Beudi कौन?
POD.
Ah, POD. I thought
POD.
you were telling Beudi. Yes, POD, correct. POD. In that, who is hypotenuse in POD?
PO.
PO.
OP is hypotenuse, yes. Chalo. So because we want R square, then I thought ऐसा कुछ है क्या triangle जिसके अंदर 90 degree है? So in a right angled triangle POD, गलती से बेवड़ी मत बोल देना, POD. OP square is OD square. राइट एंगल किधर था? PDO पे था लगता है. So that we don't do any mistake in 1-1 correspondence. PDO. OP square equal to OD square plus PD square. Correct?
Yes, sir.
What is OD? Is it OC plus CD?
Yes, sir.
Okay. So this is OC square plus twice of OC into CD plus CD square plus PD square. What is CD square plus PD square? Can you see the triangle?
PC square.
PC square, yes. PC square, yes. Perfect. Now OP square equals to OC square. OC is R.
Yes, sir.
2 times R into CD plus PC square. I am interested in MR square. R square I got. Now I'm multiplying throughout by MI. Multiplying throughout by MI. We get MI OP square is MI R square plus 2R MI into CD plus MI into PC square. Now taking summation because moment of inertia we want. Taking summation throughout we get. Please copy this much.
Done, sir.
Okay. Everybody is done?
Yes, sir.
Taking summation throughout, we get left hand side, it is summation of mi op square, correct?
Yes, sir.
Right hand side, what is first term?
MI.
mi r square. Then 2r mi summation of cd plus summation of mi pc square. I think this is what we got after taking summation. Am I right?
Yes.
Yes, sir.
This is rigid body. This is O. This is P. So this is distance from this axis of rotation. This is the distance from axis of rotation. So is it mi op square is moment of inertia about axis passing through O?
Yes.
Summation of mi means total mass, which is m, because r is constant. This r is not radius, it was distance between two parallel axes, which is constant. So r square summation of mi is r square into total mass. Okay.
Yes.
PC square means distance from C, so that is IC plus 2R mi summation of CD. So I got the answer with this extra bonus term. If this I can prove 0, I get IO equal to IC plus MR square. Clear?
Yes.
Hello? So I have to think how this can be brought to 0. 2R mi summation of CD. We have to check how we can bring it to 0. Again, copy this 2 line, then I will explain how it will be 0. I'm multiplying by G and dividing by J. Here write summation. This mi take inside summation. Written?
Yes, sir. Done.
Now, thoda we will move in 11th standard. Is this rigid body?
Sir.
What is mi? Is it mass of particle? It is m1, m2, m3, m4, so many particles, na? What is m1g called as? M1g is called as what? What is
Force
M1g?
acting.
M1g is force acting. Slightly go ahead. Which force? Gravitational force? This is gravitational force.
Yeah, sir.
So if C is center of mass, then what is CD into M1g? Is it moment of force due to gravity? Mi means एक particle का mass, mij means force due to gravity, into cd means moment of force due to gravity. About center of mass, we all know body is balanced about center of mass. So what is net moment of force due to gravity about center of mass? Is it 0? Again say 1 minute. MIG means force due to gravity. I hope everybody has understood this point. Anybody who is not knowing force due to gravity is mg, which is actually weight? Everybody knows this?
Yes, sir.
Yes.
Now MIG means force due to gravity and CD is perpendicular distance of force from center of mass. So force into perpendicular distance, is it moment of force?
Yes, sir.
Yes, moment of force due to gravity. At center of mass, we all know body is balanced. Balanced means total moment of force due to gravity should become 0 or not? By
Yes, sir.
condition of equilibrium, yes. Copy till this now. MIG is force due to gravity into CD is moment of force due to gravity, but body is balanced at center of mass. So total of all moment about center of mass must be 0.
Done, sir.
Okay. So IO is IC plus MR square plus 2R upon G into 0. So IO equals to IC plus MR square plus 0. So IO equals to IC plus MR square. This is formula. This is parallel axis theorem. Copy this 3 lines. I think completed.
Yes, sir.
Okay. What is moment of inertia of particle? of particle?
Summation of mi into ri.
If it is particles, then you will say summation of mi ri square. But in rigid bodies, which is uniform, particles are not situated at one point. It is uniformly distributed. So for that, bodies like for ring, moment of inertia about transverse axis. Transverse axis means perpendicular axis passing through its center, comma I is mr square. Proof you don't have, so I just wrote formula of moment of inertia of ring. Like if this is ring, axis is passing through center, moment of inertia is mass into r square. Please copy again 2 point. This is disk. So for this I, that's why I was telling paper this chapter is easy, but this by hearting will become difficult. All rigid body will have different formula of I. Solid sphere about diameter. So for solid sphere, axis is passing about diameter. I is 2 by 5 mr square. No proof, directly you have to remember. Done? Ring, disc, solid sphere. This is asked in major. Yes, done?
Yes, sir, done.
Okay. Fifth one. For hollow sphere. Hollow sphere about diameter I is 2 by 3 mr square. Sixth. For hollow cylinder. Hollow cylinder means when you cut, we will get ring. So I is like ring, mr square. For solid cylinder, when you cut, it will look like disc. I is mr square by 2. Two more we have to remember. 7 done, 2 more. moment of inertia of thin uniform rod about axis moment of inertia of thin uniform rod about axis passing through center and perpendicular to length. Thin rod, moment of inertia about an axis passing through center, I equal to m L square upon 12. Nine. Moment of inertia of solid cylinder about an axis passing through center perpendicular to length, not to area of cross section but length. So this is cylinder having radius r, length L, moment of inertia about center V1, passing through center and perpendicular to the length. So first one, it will behave like this. About diameter, I will prove how it is mr square by 4 plus ml square by 12. So important one because it is first one where we are having two terms, mr square by 4 plus ml square by 12. Again, if you are done, please tell me. Yes, done.
Yes, sir.
Now application of parallel and perpendicular axis theorem to this rigid bodies will do. First one, show that moment of inertia of thin rod moment of inertia of thin rod, so that moment of inertia of thin rod at one end is ml square by 3. You have to please by heart this statement I'm proving here. So this is suppose rod of mass m, length l, about standard axis its moment of inertia is ml square by 12. We want at one end. Can you tell me what will be this length, this distance?
L by 2.
L by 2. So by parallel axis theorem, these two are parallel. These two axes are parallel.
Yes, sir.
Yes, sir.
So IO is like I at one end, that is IA equals to IC plus M into square of distance. Same formula. Yes, followed.
Yes.
IC is nothing but ml square by 12 plus ml square by 4. So LCM is 12. So it is ml square plus 3 ml square. That means it is 4 ml square by 12. That means it is ml square by 3. Got it?
Yes, sir.
And you have to remember this for solving MCQ. Moment of inertia of thin rod at one end is ml square by 3. Moment of inertia of rod at one end is ml square by 3. At the end, I will take attendance, so you have to wait before leaving. Okay. Second one. Derive expression for moment of inertia of ring about diameter. Diameter is in the plane or perpendicular to the plane?
In the plane.
Very good. Diameter has to be in the plane. So if this is ring about this axis passing through center, we have to by heart. I said proof is excluded from the syllabus. So moment of inertia about the standard axis, by hearting it is mr square. But we are interested about diameter. Diameter means it passes through center. Hello?
Yes.
Yes, sir.
Passes through center and it is in the plane. So this is, if x-axis, I can call this as y-axis. This I can call z-axis. And x, y are perpendicular. Okay. Hello.
Yes, sir.
So let Ix, comma Iy be moment of inertia of ring about diameter. Therefore, I about x, I about y is I about diameter. I wrote ID. Are these three axes x, y, z perpendicular to each other?
Yes, sir.
So can I use by perpendicular axis theorem? Ix plus Iy is Iz, correct or not? So I diameter plus I diameter, Iz means passing through center wala. What is I diameter plus I diameter? Double or not?
ID.
2id, and this is mr square. So can I say id will become mr square by 2? Solve. Moment of inertia of ring about diameter is mr square by 2, or you can remember ic by 2. Completed. Yes, ring wala completed full.
Yes,
No?
sir.
Yes, okay. Third one, right? Derive expression for moment of inertia of disk about diameter. Same thing with small changes. Draw diagram again. So same word. Let Ix, Iy be moment of inertia of disk about diameter. So Ix plus Iy is Iz, I diameter, Ic, 2id is Ic, which will become mr square by 2. So final answer mr square by 4. Mr square by 4.
That's
Everybody has completed till this.
yes,
No,
sir.
Complete, so that one more topic I can do, rolling kinetic energy.
done, sir.
Obtain expression for rolling kinetic energy of rigid body. What is meaning of rolling? Rotating or translating?
Rotating.
When we say rolling, that means it is rotating also and translating also. ऐसा ऐसा आगे जाता है ना. So rolling kinetic energy is sum of translational kinetic energy and rotational kinetic energy. Therefore, rolling kinetic energy is translational kinetic energy plus rotational kinetic energy. Avan, what is formula for translational kinetic energy?
Half mv square.
And for rotational?
Half I omega square.
Correct. So this is half m v square plus half I omega square. I in terms of radius of gyration is always mk square, irrespective of whether ring, disk or solid sphere or hollow sphere. And omega we know from last year, it is v by r. So v square by r square. Anything you can take common? Half mv square is common. Hello? Half mv square in bracket 1 plus k square upon r square. This is rolling kinetic energy. Complete full. So rolling kinetic energy is half mv square 1 plus k square upon r square.
Answer.
Is derived last one expression for velocity when rigid body at rest rolls down inclined plane. Last for today. This is one plane, inclined angle theta, height is h, a rigid body at rest rolls down the inclined plane. We want velocity at bottom. When body comes down at bottom, is there loss in potential energy
Yes.
which gets converted into rolling kinetic energy? Correct, no?
Yeah.
Consider a rigid body of mass capital M to be at rest on a plane inclined at an angle theta at height h. At rest on a plane inclined at theta at height h. When it rolls down, then by law of conservation of energy, loss in potential energy is gain in rolling kinetic energy. Okay, please copy till this. Two more lines so that I can conclude. Loss in potential is mgh, gain in kinetic half mv square 1 plus k square upon r square. So m gets cancelled, 2gh is v square into that. So v will become root of 2gh upon 1 plus k square upon r square.
चलेगा नहीं ठीक है नॉर्मल मंगा लो सेम रहता है
Completed? Everybody has completed full?
Yes, sir.
Yes,
That's
sir.
all. Now theory actually we have done. एक छोटा सा theory है, एक 15 मिनट का काम है, next lecture we'll do. So next class Monday we'll start with MCQ of this chapter.